In this video, we're going to talk about division by a monomial. And before we can get to those problems, we want to recall the quotient rule for exponents. This is the rule that lets you divide powers of the same base. And so when you're dividing powers of the same base, this rule tells you that you keep the base, and you're going to subtract the exponents. Okay, so we'll be using that in the following examples. So here's the first example. We've got x to the 6 minus x cubed divided by x squared. So what we want to do here is split this up and make them single fractions. So I'm going to write x to the 6 over x squared minus x to the third over x squared. So notice how I kept the denominators and split up the fractions. Now we're going to use our quotient rule. And so here, recall we're going to keep the base and subtract 6 minus 2. So x to the 6 minus 2 is 4. Minus, and here again, keep the base, subtract 3 minus 2, which gives us x to the 1, or x. Okay, let's try another one. Again, here we have a binomial, y to the 4th plus y cubed divided by y. So let's split that up. That's y to the 4th divided by y, plus y to the 3rd divided by y. And y to the 4th divided by y, there's an exponent of 1 here, as you know. And we're going to subtract these two exponents, so we get y cubed. 4 minus 1 is 3, plus, and here, y to the 3rd divided by y to the 1st. Keep the base, subtract the exponents, we get y squared. Okay, let's look at the next one. Here we have 4b to the 8th minus 12b to the 5th divided by 8b to the 3rd, 8b cubed. So again, we're going to split those up into fractions. 4b to the 8th over 8b cubed minus 12b to the 5th over 8b cubed. Now, the coefficients, we're going to treat that like a fraction. And so 4/8, we know that reduces to 1/2. So we're going to have 2 on the bottom here. And then for our b's, we're going to keep the base and subtract 8 minus 3, so we get b to the 5th. So b to the 5th over 2 for the first fraction. Minus, okay, 12/8. 4 goes into 12 3 times, and 4 goes into 8 twice. So we know we have a 3 in the numerator and a 2 in the denominator. And our b's, we're going to keep our b and subtract 5 minus 3, so we get b to the 2nd power. Okay, let's look at the next one. We have a trinomial, 3y squared plus 6y minus 9 divided by 3y squared. So let's split those up. 3y squared over 3y squared plus 6y over 3y squared minus 9 over 3y squared. So notice in the first fraction that we get the same numerator and the same denominator. So we know that those reduce to a 1. So we get a 1 for the first. The 3's reduce and the y squares reduce, and we get 1. In the next fraction, 6 and 3 have 3 in common. So we have a 1 here and a 2 here. And then I want you to notice something. Let me put that 2 here and that 1 there. Okay. Then I want you to notice that the bigger exponent is down here. So we can use our quotient rule and subtract this 1 from this 2 in the bottom. So that will keep our y down here, and this is going to be 2 subtract 1, which will be 2y to the 1st power. So by keeping track of where the bigger exponent was, then that kept us from having negative exponents. Okay, so that's just a technique. And then here in the third fraction, we know that 3 goes into itself once and into 9 3 times. There's no y up here, so our y squared is going to stay here. So this is minus 3 over y squared. So our final answer is 1 plus 2 over y minus 3 over y squared. Okay, we've got one more here. We've got 15x squared minus 5x plus 10 divided by 5x. I'm going to split those up, make separate fractions, and then I'm going to reduce. Okay, in our first fraction, 5 and 15 have 5 in common, which leaves us with a 3 and a 1. And x squared divided by x to the first, we're going to subtract. The larger exponent is on top, so that's going to stay on top. So we get 3x for the fraction minus 5x divided by 5x is 1 plus, and now 5 goes into 10 twice. We don't have any more x, so that x stays down there. So we write 2 over x.